We'll now begin section 4.2, where we will discuss polynomial division. Our definition for polynomial division says, let p of x and d of x be polynomials such that d of x is not equal to 0, and with the degree of d less than or equal to the degree of p. Then there are unique polynomials, q of x and r of x, called the quotient and the remainder respectively, such that p of x is equal to q of x times d of x plus r of x. Now, basically what they are doing here is simply defining the terms quotient and remainder. Let's do this with a simpler example so that you can see how these terms relate to one another. So I'm going to step away from a polynomial right now and go to what we know about regular numbers and division. So let's say, for example, that we were asked to divide 17 by 5. So we know that when we do that, when we divide 5 into 17, we know that 5 goes into 17 3 times, and it leaves a remainder of 2. So in this case, 17 is our dividend. That's our p of x. And the divisor, what we're dividing by, is 5. So when we work out the problem, we come up with a quotient of 3 and a remainder of 2. And so we can say that 17 is equal to 3 times 5 plus 2. And so again, on this slide, they're basically wanting you to recognize terminology, that the dividend is what you're dividing into, the divisor is what you're dividing by, the quotient is what you get when you do the division, and the remainder is what is left over. Either the degree of the remainder r is less than the degree of the divisor, or the remainder is 0, in which case we say that d divides evenly into the polynomial. If the remainder is 0, the two polynomials q and d are factors of p. So what this means is that if we do a division problem and we get no remainder, for example, let's say that we were taking 20 and dividing it by 5. And we know that that goes 4 times. 5 times 4 is 20, and we end up with a remainder of 0. So if the remainder is 0, then the two polynomials q and d are factors of p. So in this case, 5 and 4 are factors of 20. And so you want to be able to recognize that if you do a division problem and the remainder is equal to 0, then what you divided by and also your quotient, those both are factors of what you started with. The number k is a 0 of the polynomial p of x if and only if the linear polynomial x minus k is a factor of p. What this tells me is that if I have a polynomial, say I have x minus 3 times x plus 4, we know the zeros of this would be 3, because that would cause this term to equal 0, and also negative 4. So what this statement is saying is that if you have a 0 like 3, then you have to have x minus 3 as a factor. Or if you have a factor of x plus 4, you have to have negative 4 as a 0. That the zeros and the factors are related in that manner. All right, and the last statement that we have talks about what we call the remainder theorem, which says that if your polynomial is divided by x minus k, the remainder is p of k. All right, and again, that is just defining this part of the expression as the remainder. Okay, so let's begin by looking at an example. Divide the polynomial x squared plus 2x minus 24 by the polynomial x plus 6. And so we want to look at our procedure for how we're going to do this. We want to first be sure that when we're underneath our division, we have all the powers represented. So if we're starting with a squared, we then have a first, and then we have nothing for the x. If you happen to be missing one of those terms, you want to hold that place with a 0. So we want to begin by comparing our first term here to our first term here and asking ourselves, x times what would make x squared? And x times x would make x squared. We're then going to multiply both of these terms on the left-hand side by x and write it underneath. So x times x is x squared. X times 6 is 6x. And the idea is that we want to subtract those off. And we have to be careful with our signs. So I'm going to put this in parentheses and put a subtraction on the outside. So x squared minus x squared, that falls out to be nothing. And it always should if we've done things correctly. Okay, and then I'm going to move to the 2x. And what I do, I'm going to write it down over here. So I've got 2x. I've got a subtraction on the outside, and then I've got 6x. So looking at that, 2x minus 6x is going to give me a negative 4x. And then I'm just going to drop that minus 24 down. Now that completes one cycle of our problem. So now we're going to move on and we're going to go to cycle 2. So we are going to compare this first term here to the first term here and ask ourselves, x times what would make negative 4x? And that would be negative 4. X times negative 4 makes negative 4x. We'll then multiply that negative 4 by both of these terms on the outside. So negative 4 times x makes negative 4x. Negative 4 times 6 makes negative 24. We're going to subtract and put it in parentheses. And we're going to look at what we have now. When we expect this first term to fall out, which it does because we have a negative 4x. We have a minus on the outside of the parenthesis. We have a negative 4x on the inside. And so this subtraction and this minus become plus a positive, and that becomes 0. Now, actually, the same thing happens with the 24. We've got a negative 24. We've got a subtraction on the outside. Inside the parenthesis, we have a negative 24. So this subtraction and this negative become plus a positive, and we get 0. So the quotient is x minus 4. And the remainder is 0. So what does that tell us in addition to noting the quotient and the remainder? Since the remainder is 0, we know that x plus 6 and x minus 4 are factors of x squared plus 2x minus 24 because the remainder was equal to 0. Okay, so let's move on to another example. All right, and the examples you'll see will get just a little bit harder with each one that we do. This one we want to divide 6x to the 5th minus 5x to the 4th plus 10x to the 3rd minus 15x squared minus 19. Okay, and right now I'm going to check and make sure I've got a 5th, a 4th, a 3rd, a 2nd. I'm missing the first, so I'm going to need to, when I write this problem down, I'm going to need to insert a plus 0x, and then I have my 19. And we're dividing by the polynomial 2x squared minus x plus 3. So we'll go ahead and set it up. You can see that the 0x has been inserted, and we're ready to start working the problem. Okay, so comparing the first term to the first term. 2x squared times what to make 6x to the 5th? Well, we know that 2 times 3 equals 6. We have 2 x's on the outside. We need 5, so I'm going to put an additional 3. So 3x to the 3rd is the first part of our quotient. We're going to multiply. So 3x to the 3rd times 2x squared makes 6x to the 5th. 3x to the 3rd times negative x makes negative 3x to the 4th. 3x to the 3rd times 3 makes 9x to the 3rd. We're going to put that in parentheses and subtract. The first terms will fall out. Then we have a negative 5x to the 4th minus a negative 3x to the 4th. So the subtraction and the negative become plus a positive, leaving me negative 2x to the 4th. On my cubed terms, I have 10x to the 3rd minus 9x to the 3rd. That gives me an x to the 3rd. And then everything else I'm going to just drop down. So minus 15x squared plus 0x minus 19. All right, so we'll go back and we're going to compare the 2x squared on the outside to the negative 2x to the 4th on the inside. 2 times what makes negative 2? That would be a negative 1. X squared times what makes x to the 4th? That would be an x squared. Then we need to multiply. So negative x squared times 2x squared would make negative 2x to the 4th. Negative x squared times negative x would make positive x to the 3rd. Negative x squared times 3 would make negative 3x squared. Put it in parentheses and subtract. We expect the first terms to fall out. The next set we have x cubed minus x cubed, so that's going to zero out as well. Then we have, we'll come off to the side, negative 15x squared minus a negative 3x squared. Minus a negative becomes plus a positive, which gives me negative 12. Sorry, back to it. It gives me negative 12 x squared, and I'm going to drop the rest, plus 0x minus 19. All right, and we're going to try it one more time. So we're going to compare the 2x squared on the outside to the negative 12x squared on the inside. 2 times what makes negative 12? That would be a negative 6. Then we're going to multiply. So negative 6 times 2x squared would be negative 12x squared. Negative 6 times negative x would be positive 6x. Negative 6 times 3 would be negative 18. We're going to put it in parentheses and subtract. Again, we're going to want to assume that the first term will fall out if we've done it correctly. Then we have 0x minus 6x, which gives me a negative 6x. And I have negative 19 minus a negative 18 plus a positive gives me negative 1. Okay, so our quotient is 3x cubed minus x squared minus 6. Our remainder is negative 6x minus 1. Now you might be asking, why did we stop there? We stopped there because there's no way to multiply something by 2x squared and only get something with an x. So as soon as this power of x becomes less than what we started with, we're done. Now, the other thing to note is in terms of writing our solution, sometimes we see the solution written all as one term instead of written separately as the quotient and the remainder. So an alternate way to write your solution would be to write, put it down here, would be to write 3x cubed minus x squared minus 6, that's the quotient part, and then write plus, and we're going to write this remainder as a fraction, so minus 6x minus 1 over what we divided by, so 2x squared minus x plus 3. And so this is sort of an alternate way for you to write your solution. Okay, we're going to do one more example here. This one involves a complex number, so that makes it a little more difficult to work with. We're going to divide p of x, which is x to the fourth minus 1. Okay, so lots of things that I am going to need to add in here. I'm going to need a 0x to the third and a 0x squared and a 0x plus 1. And then the divisor, what we're dividing by, is x squared plus I. All right, so let's set it up. On the outside, you can see that we have x squared, and the I, we did add in that 0x there. And then underneath, we have x to the fourth plus 1, but we have the places held for 0x to the third, 0x squared, and 0x. So let's begin by looking at our first term. So we look at the x squared. And we look at the x to the fourth. X squared times what makes x to the fourth? That would have to be an x squared. We're then going to multiply. So x squared times x squared is x to the fourth. X squared times 0x is 0 x to the third. X squared times I is I x squared. We're going to put that in parentheses and subtract. The first term will fall out, x to the fourth minus x to the fourth. The second term is inconsequential anyway because it's a 0x to the third minus a 0x to the third, so we no longer need that. And then we have 0x squared minus I x squared. So that's going to be a negative I x squared. And then we're going to pull the rest of this down. So we now have negative I x squared plus 0x plus 1. All right, so we're ready to go on one more cycle. So x squared and negative I x squared. So x squared times what? To make negative I x squared, we would need a negative I. So now we are going to multiply. Negative I times x squared, negative I x squared. Negative I times 0x, that would stay 0x. Negative I times positive I would be negative I squared. Put it in parentheses and subtract. The first terms again fall out. The second terms, the 0x's don't matter because they're both zeros. So the only thing that we have to work with here is the 1 minus a negative I squared. So let's kind of simplify this a little bit. This becomes 1 plus a positive I squared. Remember that I squared is the same thing as negative 1. And so when we substitute that in, we end up with 0. So the remainder is 0 and we're done. So our quotient is here. X squared minus I. Our remainder is 0. And so we know now that, remember, if the remainder is 0, that gives you an indication of the factors. So that tells you that x squared minus I and x squared plus I, which is what we have out here, are factors of x to the fourth plus 1.